Good day, viewers. Welcome you to class again today on numerical analysis. Today we shall be looking at numerical integration part 2. The last time we considered numerical integration part 1. We dealt with the trapezoidal rule, the Simpson's 1/3 rule, and the Boole's rule. Today we shall be looking at the Weddle and Simpson's 3/8 rules. These rules are good rules. They are good for numerical integration. Beloved, before I go into the class fully, it will be good I introduce myself to you. Once again, my name is Dr. Chris Esekaibe. I am a chief lecturer in one of the most prestigious polytechnics in Nigeria. It's a very awesome polytechnic. I rose from the rank of lecturer 3 to the position of chief lecturer. I got that promotion in year 2023. I have lecturing experience in university. I've lectured in an open university, and I've also lectured in an A-level college, a pre-university college in Abuja, where I taught mathematics in Cambridge A-level. I've produced students with grade A in Cambridge A-level mathematics, and also the IFG program, International Foundation Group, with the UK, and also the Canadian Ontario Diploma, where I taught functions and calculus, advanced calculus. So I have produced students with A grade at the pre-university college in Abuja, and I've also lectured in the university and open university, and presently I'm a chief lecturer. That is the peak position, academic position in the polytechnic system. By the special grace of God, I've attained that. I've been teaching for the past 20 years, so my wealth of experience is what I have brought to my channel to enable people across the globe to benefit from this. So please always watch my video to the end. Subscribe to my YouTube channel, Dr. Chris Esekaibe. Each time you subscribe, anytime a new video is uploaded, you will get a notification alert, and so that you will be able to watch the video. Share the video in your social media platforms and the rest of them. Like my videos and click on the bell button. Please, if you want to contact me, peradventure you want me to join in your group, in your research group, or you have a research work you want us to do together, or you have a problem that you want me to assist you with the solution. Today, this is the very first time I will be writing my contacts, so that viewers all over the world will have access to my contacts. If you want to contact me for any research work, any group work, any team work, for my input, I'm very much available for that. I'll create time for that. My contact numbers are +234, because I reside in Nigeria. I work in Nigeria. I work in a prestigious polytechnic, a renowned polytechnic in Nigeria. And by the grace of God, I rose from the rank of lecturer 3 to the rank of a chief lecturer. So I'm a chief lecturer in the polytechnic. I have a wealth of experience. So these are my contact number. If you want to contact me for research work, for anything that you feel my input will be necessary, reach me on these numbers: +234 8033021903 or +234 7066 297535. Again, +234 8033021903 or +234 7066 297535. Reach me on any of these two numbers. There are also my WhatsApp numbers. You can send a WhatsApp message, or you can reach me on my email address, chrisdavids2015@gmail.com. I want to assure you, whatever challenge you bring, we'll look at it together. We'll rub minds together. I believe in sharing of knowledge. The essence of creating this YouTube channel is to share knowledge across the globe, to have my input in solving problems in mathematics and statistics. And as you do that, God will bless you on every side. So permit me to continue now with our class for today. Write the numbers down, write the email address down, and contact me with your mathematical problems, with your research problem. If it's a research institute, you want me to be part of the institute, you want me to review papers for you, papers for publication, or whatever thing you want me to do. Once again, I hold a bachelor degree in statistics with a very sound grade, a master's degree in mathematics, and a PhD in mathematics. My area of specialization is numerical analysis. I also specialize in data analysis and modeling, statistical analysis, scientific computing. So I specialize in scientific computing, and I'm an applied mathematician and a statistician. So please reach out to me wherever you are across the globe. We'll be able to sort out whatever issues you have. God bless you. So permit me to clean this up so that we can continue with our work for today. Thank you very much. Wait patiently to the end of this class and watch and see how you can use the Weddle's formula to solve or to carry out a problem on integration. What we have on the board now is the Weddle's formula. For the Weddle's formula has n to be equal to 6. This formula was derived from the Newton's forward interpolation formula. When that formula was integrated and n was set to 6, they came about this formula. The Weddle's formula was derived when n was equal to 6. The Newton's forward difference interpolation formula was integrated. That polynomial was integrated and n was set to 6, and the result is this Weddle's formula you are looking at. We looked at the trapezoidal rule. Trapezoidal rule, n was set to be equal to 1 when that Newton's forward difference interpolation formula was integrated. N was set to 1 and the trapezoidal rule was gotten. When n was set to 2, the Simpson's 1/3 rule was gotten. When n was set to 3, the Simpson's 3/8 rule was gotten. We'll get to that one. Then when n was set to 4, we got the Boole's rule. We used the Boole's rule, the Boole's rule, the Simpson's 1/3 rule, and the trapezoidal rule in our last video. So today we shall be looking at the Weddle's rule and the Simpson's 3/8 rule. Remember, when you are given the essence of numerical integration is when you are given a set of number or a set of data points as x0, y0, x1, y1, x2, y2, down to xn, yn. All these data points, they are from a function which is called a function of y equal to f of x. So they are gotten from this function, they are obtained from the function. These data points, they are of this function. In a case, there are situations where this one will be unknown. It is not known explicitly. Not known explicitly. So when the data points are known and the function itself is not known, we can carry out integration. When the function itself is known, we can also carry out integration. We can also carry out integration, and the integration we are talking about is definite integral. The integration is of this form: I equal integral b to a. So it's definite y dx. So this y is a function of x, and it's got these data points are gotten from this particular function. But there are situations where the data points are known and the function itself is not known. So we can still carry out numerical integration, unlike the situation where you have the function, whether the function is known or the function is not known, you can still carry out numerical integration once the data points are gotten. But when you are carrying out the conventional integration, or you are using the true method of solution. If the function is not known, integration is not possible. So this one is also given as this particular function from is also integral xn to x naught y dx. So you can see y is a function of x and the problem is definite integral. Remember, we have two types of integrals, definite and indefinite integrals. The one with the upper bound and lower bound is called the definite integral. So this is the kind of problem we shall be solving when the data points are given. Very necessary. We need it for numerical integration. Now, permit me to pick a particular problem and solve using these two methods of solution, so that we can now compare the error with the true solution. We'll go ahead and compare the error from the true solution. Now, if I have a problem as this, if I say integrate integral 3 to 0 bracket open 1 plus x squared dx. If I say we should carry out this integration now using the Weddle's rule and the Simpson's 3/8 rule, the first thing we need to do is to get what we call the true solution. True solution. If I want to get the true solution of this, I will have it as integral 3 to 0 1 plus x squared dx. If I carry out this integration, remember the general integration formula. Permit me to write it out. If I have integral x raised to power n dx, this will be equal to x raised to power n plus 1 all over n plus 1 plus c. The integration constant must be added. This is an indefinite integral, but in the case of definite integral, the integration constant will definitely vanish out. It will cancel out. So integrating the constant with respect to x will be x. Unlike differentiation, if you differentiate a constant with respect to any variable, it will be 0. But when you integrate a constant with respect to a variable, it becomes that variable. So this will now be x plus, if I integrate x, it will be x squared over 2. If I integrate x squared, it will be plus x raised to power 3 all over 3. This is x raised to power 1. 1 plus 1 is 2 all over 1 plus 1. This is 2. 2 plus 1 is 3 all over 2 plus 1. Then, of course, like I said, for definite integrals, the integration constant will cancel out. So we have our upper bound to be 3 and our lower bound to be 0. Now, putting these values in, I'm going to have where x with the upper bound will take the value of x first. This will be 3 plus 3 squared over 2 plus 3 raised to power 3 all over 3, then minus 0 plus 0 squared over 2 plus 0 raised to power 3 all over 3. So this will now be equal to, you open the bracket, this will be 3 plus 3 squared is 9. It will be 9 all over 2 plus 3 raised to power 3 is 27. 27 all over 3, then minus 0. So the solution to this problem using the true method, 1 plus x squared dx, the solution will now be equal to 3 plus 4.5 plus 27 divided by 3 is 9 plus 9, and that will be equal to 16.5. So our answer is 16.5. So take note of this solution. This is the true solution using the conventional method that we know. Now we want to go ahead to use the numerical method, the Weddle's formula, to carry out this particular integration and see if we are going to arrive at the same answer, 16.5. Now let us go ahead and use the Weddle's formula. Please take note of this answer, 16.5. Now we want to go ahead and see how we can use the Weddle's formula to carry out this particular integration. Now, you know, the problem again is, permit me to write it here, integral 3 to 0, 1 plus x squared dx. That is our problem. Then writing this out, it simply means that our y will be equal to 1 plus x squared, because y is a function of x. Look at the problem here, integral x6. So for the Weddle's rule, n is 6. That's why it's starting from x6 to x0. So we are this h, we are going to calculate h. H will spread the values of x from x0 to x6. That's what h will help us to do. H is the mesh size. So now from here, let us get our h. Our h will be equal to, our b is 3, our a is 0, to be 3 minus 0 all over 6. Our n is 6. This will be 3 all over 6 is equal to 0.5. So for this particular problem, our h is 0.5. So this will now lead us to creating a table of x and y. So we are going to create a table of x and y. Remember, x runs from 0 to 3 and is increasing per time with h. H is the step length. So our first value for x is 0. You add 0.5, which is the value of h to it, it will be 0.5. Add 0.5, it will be 1.0. Add 0.5, it will be 1.5. Add 0.5, it will be 2.0. Add 0.5, it will be 2.5. Add 0.5, it will be 3.0. You stop. So you can see x is taking value from 0, 0.5, 1.0, 1.5, 2.0, like that. So permit me to rule it out so that we can get it accurately. And so on and so forth. So we are going to get the corresponding values for y using y is equal to 1 plus x squared. Now let us go. When x is 0, 0 plus 0 squared is 0 plus 1, y will be 1. When x is 0.5, 0.5 plus 0.5 squared plus 1, we are going to get 1.75. Then when x is 1, you have 1 squared is 1 plus 1, 2 plus 1, 3. You are going to have 3. When x is 1.5, you are going to have 1.5 squared plus 1.5 plus 1. You are going to have 4.75. 4.75. When x is 2 squared is 4. 4 plus 2, 6 plus 1, 7. When x is 2, you are going to have 7.0. Then when x is 2.5, you are going to have 2.5 squared plus 2.5 plus 1. You are going to have 9.75. You are going to have 9.75. Then when x is 3, 3 squared is 9. 9 plus 3 is 12. 12 plus 1 is 13. You are going to have 13. So we have created a table having values for x and y. So now what we are going to do is to go ahead and calculate using the Weddle's formula. So now we are going to have integral 3 to 0, 1 plus x squared dx, and that will be equal to 3h. Remember, our h is 0.5. This will be 3 into 0.5 all over 10. Then bracket open. Look at it here now. It's very easy. This is y0, y1, y2, y3, y4, y5, y6. So it will share it from y0 to y6, because the Weddle So its upper bound is x6 and the lower bound is x0. So it will definitely share it from x0 to x6 or from y0 to y6 because they are pair, the values are pair. They are pair values. So now you are going to have, here will be your y0, here will be your y0. Okay, don't just leave it out like that. Y0, y1, y2, y3, y4, y5, y6 is complete. So now the first one is y0, which is 1 plus 5y1. 5 into what is our y1? Our y1 is 1.75. Then plus the next one is y2. Our y2 is 3 plus 3 plus the next one is 6y3 plus 6 into y3 is y1, y2, y0, y1, y2, y3 into 4.75. Then the next one is plus y4. Y4 is 7 plus 7. Then the next one is y5 plus 5 into 9.75. Then of course plus y6. Our y6 is 13. So you cover the bracket. Okay, permit me to write it here. You can have it like this, plus 13. Then you cover the bracket here. Permit me to put it there like that. So you are going to have this as, when you now begin to open the bracket, you have 3 times 0.5, that would divided by 10, you are going to have 0.15. So this will be equal to 0.15 into, this will be 1 plus 5 times 1.75, that will give you 8.75. 8.75 plus 3, we have our 3 plus 6 times 4.75 is 28.5 plus 28.5 plus, of course, our 7 is here, plus 9 times 5.75 will be 48.75 plus 48.75, then of course plus our 13. Then you cover the bracket. When you add all these together, you are going to have 0.15 into, when you add everything together, you are going to have 110. You add 1 plus 8.75 plus 3 plus 28.5 plus 7 plus 48.75 plus 13. When you add it up, you will get 110, and 110 multiplied by 0.15, again you are going to get 16.5. So you can see that is the correct answer that we got using our true method, 16.5. Can you clap for yourself there now? You can see how easy the Weddle's formula is. So this simply means that from here now you want to get your truncation error. Your T error will be equal to 16.5, which is the okay, permit me to write it here. T error is equal to true solution minus numerical solution. So our truncation error will now be equal to 16.5 minus 16.5 is equal to 0. So for the Weddle's formula, it is the truncation error is 0. It means that that particular method is error free. You can see the Weddle's formula is error free for this particular problem. So you can see how reliable and how dependable numerical methods or numerical analysis can be. In the situation where you cannot even reach the function f of x, y is equal to f of x, and you have the data points from the data set, you can carry out your numerical integration, even your numerical differentiation. This is how important. So the numerical analysis has helped really in solving real life problems, in applying numerical methods in solving real life problems where conventional methods are really not can really not achieve results. The numerical methods can go ahead and achieve results. So it's highly dependable. Like I told you, I'm a specialist in numerical analysis. I gave my numbers and my email address on this video. You can contact me. If you are a research institute, I can work with you. I can do research with you. Whatever institute, my own is just to contribute to knowledge in all parts of the world. I'm sure the language is not going to be a barrier. I speak English fluently. I write English fluently. I teach in English. I write in English. So you can contact me in any English-speaking part of the world for your numerical analysis and for your research work. Statistical analysis, mathematical analysis, numerical analysis, scientific computing, and so on and so forth. There are lots to be taught in this channel. That's why we are taking it gradually, topic by topic, step by step, and so on and so forth. By the time we finish this, we may dive into calculus. There are many areas to be taught. So we'll continue to teach topic by topic. And if you have a request for any topic you want us to teach, why not you can send me an email or a WhatsApp message via my numbers I displayed on the video. Now, permit me to go to the Simpson's 3/8 rule. We are still going to use this table. So permit me to clean this Weddle's formula. Permit me to clean it off. We are still going to use this same problem. We are going to solve this same problem using the Simpson's 3/8 rule. That is what we want to do now. So I will write the Simpson's 3/8 rule on the board. Permit me to also clean this part. So note, we have used the Weddle's formula to get the same answer with the conventional method. Now I want to teach us or show us how we can also use the Simpson's 3/8 formula. Numerical analysis is very interesting, very interesting. It's a part of mathematics that is applicable to solving real life problems. Once the problem is understood and you set up a program for it, then we can provide a necessary solution using any numerical approach. Now, the Simpson's 3/8 rule. So please, the rule is given as this: integral xn to x naught y dx. So y, of course, is a function of x. So this will be equal to 3h/8 into, please watch how I write the formula, y naught plus 3y1 plus 3y2 plus 2y3 plus 2y3 plus 3y4 plus 3y5 plus 2y6 plus, let me continue here, plus, now you now have plus 2yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. So this is the Simpson's 3/8 rule. Let me show you how this formula works. You can see the y naught is set aside and the yn is also set aside without any coefficients. This one was derived setting n to be equal to 3. This from when that Newton's forward difference interpolation formula was integrated and n was set to 3, the Simpson's 3/8 rule was derived. All these formulae we have been using on integration were derived from Newton's forward difference interpolation formula. Now look at this. Yn is set aside, y naught is set aside, yn is set aside. The first coefficient there is 3, 3, 2. Again, 3, 3, 2. You see the way it goes. Then now the third part to the yn, the 3 last y's to the yn. Again, we now start with 2, 3, 3, then the yn. That's how it goes. If I want to continue from y7 now, it will be 3y7 plus 3y8 plus 2y9 is going like that, 332, 332, 332 till you get to the last this is then the three y's before the last y will be 2, of course 3, and so on and so forth. So you study the formula. It was derived from that Newton's forward different interpolation formula, setting n to be equal to 3. Now let us quickly go and apply the formula. It's as simple as ABCD. Now we come here, our integral, okay, permit me to start it here, integral 3 to 0, 1 plus x squared dx will now be equal to, remember our h is 0.5. Remember our h for this problem is 0.5. We are using this same table. So this will be 3 into 0.5 all over 8 into, now 8, y naught is there is 1 plus 3y1, 3 into 1.75, then the next one, then 3 into y2 plus 3 into 3, you see it, then the next one is 2 plus 2 into 4.75, you see that? Then when you take 3, you take 2, you take 3 again, then plus 3 into 7, then permit me to continue here, plus 3 into 9.75, and of course the last one is reserved, plus, you can see the formula 3 before the last one, so you can see 3 before the last y, which is plus 13. So you have that. So that is how the formula is applied. So it's y naught, which is 1.0, then 3 into y1. Y1 is, this is, permit me to write it, this is your y, this is your y naught, this is your y1, this is your y2, this is your y3, this is your y4, this is your y5, this is your y6. Now the Simpson's 3 over 8 rule can take as many value of y, maybe up to y10 or whatsoever. You just continue in the formula. It's not unlike the Weddle's rule that it must have x naught to x6, the Weddle's rule. But for the Simpson's 3 over 8 rule, you can have as many y's up to y20. What you just need to do is to be applying the formula. But we are just using it to solve the same problem and see the result we are going to get. So now you can see from here, let's see it again, y naught is 1.0, so you have 1, then plus 3y1, 3 into 1.75, plus 3y2, 3 into 3, y2 is 3, then plus 2y3, 2 into 4.75, then again plus 3y4, 3 into 7, y4 is 7, then plus 3 into y5 is 9.75, then of course the yn, the last y is reserved. So you can see a 3 before the last y, like that it keeps running. So these formulae are very easy to understand. So continuing, here you have your 3, your 0, 1 plus x squared dx, it will now be equal to, so you see that this particular formula is very easy to apply. So we are going to have it as, when you say 3 times 0.5 divided by 8, you are going to have 0.1875. 0.1875 into, here you have 1 plus, then you now say 3 times 1.75, you are going to have 5.25. 5.25 plus 3 times 3 is 9, plus 2 times 4.75, that will give you 9.5. That will give you 9.5 plus 3 times 7. 21 plus 3 times 9.75 is 29.25. That is 3 times 9.75 is plus 29.25. 29.25. Then the last value is 13 plus 13. Then you cover the bracket. So this will now be equal to 0.1875 into, when you add all those values together, you add 1 plus 5.25 plus 9 plus 9.5 plus 21 plus 29.25 plus 13, you are going to have 88. So you are going to have 0.1875 into 88. And when you multiply this by 88, again, you will arrive at the same answer, 16.5. Clap for yourself. So you can see how dependable numerical methods can be. And you can see how dependable these methods can be. We have used the Weddle's rule and the Simpson's 3/8 rule to solve the same problem. We are arriving at the same answer. Now our truncation error will be equal to the true solution minus the numerical solution, and that is 16.5 minus 16.5, and again is 0. It means that the Simpson's 3/8 rule is error free, is 0 for this particular problem. Below you can see how we have been able to use the Weddle's rule and the Simpson's 3/8 rule to solve this problem after getting the true solution. I believe you have learned something today. Always have patience anytime my video comes up. Watch it to the end so that you can learn. The essence of this YouTube channel is to share knowledge across the globe. Like as I said, if you have research where you know I can feature in, if you are maybe a research institute or you are doing a research or you want us to co-author and do a paper on numerical analysis, or you want me to have an input in your research, it can be an institute, or you want me to be a team, a partner with you, you can send me a WhatsApp message from my numbers I displayed from the beginning of this video. Just go to the beginning of the video, you will see my numbers, my phone numbers. You can call me from any part of the world. I'm in Nigeria, like as I said. I am a chief lecturer in the prestigious Polytechnic in Nigeria, where we share knowledge for creativity, for advancement, and the rest of them. So share my videos on your YouTube, on your social media platform. Watch the videos in my YouTube channel, Dr. Chris Esekaibe. And please, you can also send me an email. My email address was also displayed on the board. Please send me an email so that we can share knowledge together. We can do great jobs together. And as you do, God will bless you. Keep sharing knowledge, keep learning, keep learning, keep learning, keep learning. And as you do, God will bless you. In my next video, I will be looking at numerical integration also, where we can be differentiating trigonometric functions. Trigonometric functions are very technical to integrate using numerical methods. The Boole's rule, the Weddle's rule, the Simpson's 3/8 rule, the Simpson's 1/3 rule, the trapezoidal rule. We shall be seeing how we can use these rules or these formulae to carry out numerical integration on trigonometric functions. So please watch out for the next video, and as you do, God will bless you. Please do have a nice day. God bless you. Bye.